So in this function, we know again we notice what's happening as we really get closer to 100%. Now let's just set our table set value to start at 90 and just go up by increments of 1. So we notice that there's this huge explosion of cost as we get into the 90s. And look at that. By just going from 95 to 96% or 96, now the cost is jumping by $0.4 billion. And as you get closer, you see those costs. Now we're in big billions of dollars, and then at 100 we have this error. Well, let's see why. So the first thing we'll do is we'll find our vertical asymptote. That's usually the easier one to find because, well, not, I shouldn't even say easier, but it involves saying, well, when's the denominator equal to 0? Well, 100 minus what equals 0? You can probably do that in your head and see that x equals 100 would be what would make the denominator 0. And now if I come over here and I build my graph, that means that at x equals 100, I'm going to have a vertical line. Okay, so what would my horizontal asymptote be, just so it gives me a better idea of what's happening to the graph? Well, my horizontal asymptote, in this case, let's rearrange this equation to make it so that the highest ordered term comes first. So down here it's 100 minus x, but minus x has is a variable with an exponent. So what I will do is just rewrite this as negative x plus 100, because remember this is really just saying 100 plus negative x. So 100 plus negative x is the same thing as negative x plus 100. Okay, well that's got a coefficient of 1, and my order in my numerator is the same as order in my denominator, and so that tells me that the horizontal asymptote is going to be the ratio of those two guys. So y equals 0.08 divided by negative 1, which if you should quickly see that that's just going to be y equals negative 0.08. So it's almost, but not quite, an asymptote of 0. Well, to us maybe that might not make sense. Well, why isn't it 0? How could you possibly have negative costs? And the answer is you probably wouldn't have negative costs. That's just how sometimes when we model using regression, things work out. Well, now, so we would want to set, when we put in our function 0, oops, we already had it in. I accidentally deleted it. 100 minus x, and now we took a look at the window so that our window went from 0 to, let's just say 110, so that way we can actually see what's happening at the asymptotal area. And we noticed that our y went from about 0 to 8 when we looked at it in the table near 100%. And here's kind of what we get. So do you see that? It's hard to see over here, but it's almost hugging this asymptote. It's really close to it. And then suddenly those costs, as the percentage increases to 100, get very, very, very high. Also, there's stuff happening over here too, but we don't really care about that because you can't clean more than 100%. So that basically tells us that as costs increase, as percent increases, percent of cleanup increases, the costs begin to skyrocket enormously. Well, let's just say we wanted to ask, okay, how much will it cost to clean 30%, or 35%, or whatever percent we want? Well, in our equation, y equals 0.08x over negative x plus 100, we want to know basically for what value of x is the y0. So we would have 30 equals 0.08x divided by negative x plus 100. Okay, so when we're solving rational functions, in other words, we're putting something in for the output, and we want to solve for the input, there's a procedure that we go about, one that works pretty well. Now, you could definitely plug this into your calculator and just plot the line y equals 30, and as usual, figure out when those two things intersect. So